Okay, boys and girls, here is what we've been talking about last day. I want to give a review if you need it, a little extra work with it. We're starting to graph our lines from patterns. We've been looking at patterns for about a week and a half now, and we're doing really well. The big thing to take away is that there are so many ways to figure out an equation from the pattern. There's an algorithmic way that we haven't even looked at yet. We'll look at in a few days that is pretty straightforward, but I don't want to teach that to you yet because I'm really enjoying watching your minds work and figure out ways to solve these patterns. So anyhow, what you see here is we have a number pattern, a straight number pattern, a picture pattern, and a word problem. All of them are going to make equations up. So we're going to figure them out and then graph them on some different graphs. Anyhow, if this is our first data set, if we're going to work on this first one up here on example 1, we know 5, 7, 9, 11. It doesn't take a genius to figure out that these all go up by 2. They're all increased by 2. And if I just had two blanks right here and I asked you to go ahead and complete the pattern, well, of course, you would just add 2 to 11, which would make that 13. And you'd add 2 to 13, which would make it 50. Now, that completes the pattern. But what we have to do is figure out an equation that'll actually let us do this. So we've got to figure out something that we can do to x, a term that will bring us to here. And because remember when we used to do, or not used to, we've been doing the nth term. So if I asked you to tell me what the 22nd blank is, you'd have to figure out some sort of equation to do it because you wouldn't want to just keep adding to 22 times. So there are so many different ways to do it. I'm going to go kind of quickly because we've done this part, and I want to get more of the pattern part, or the graphing. But anyhow, we're just fine with this. So how can I get it to be 5 and 7 and 9? What am I doing? Remember, for most part of your stuff, there will be a two-part. There will be something that happens to your variable, and then you'll either add or subtract another number. So it looks like this. There's going to be something here and then something over here. It could also be, if the numbers were getting smaller each time, it could be the variable being divided by something, and then you either add or subtract another number. So we've got to kind of, in our minds, play around with the numbers until we can get it to work out. Anyhow, when we look at 5, there are very few numbers that we're going to do, and of course it doesn't get too big. So let's just take that x variable, and let's start by leaving it there. And then maybe I'm going to add 4. X plus 4 will get me 5, but if I use my, and that was my first term, but if I use that with my second term, and I put a 2 in here, that'll only get me 6. And that will not equal that. So I can't quite use that one. That's not going to help me here. So I can't just use x by itself. But what if I used 2x? I say, okay, 2x will get me somewhere. And if I have 2x and I put the first term in there, 1, 2x, 2 times 1 will get me 2, and then I would add 3. Well, that will get me that first term there. But will it work for the second term? Well, I don't know. 2 times 2 plus 3. 2 times 2 is 4 plus 3, and that's going to be 7. And that would get me my second term. And I think I might be on to something now. Just figure out thing. And lastly, 2, and I put my third term in and add 3. 2 times 3 is 6 plus 3 is 9. And we know that we're on the right path because each of these terms work out really nice for us. So we can determine that the equation that we're going to be using is this one right here, 2x plus 3. Now, when we made our t-chart up, we just do this to check, but we've already done the math right here. This will be our first term. This will be our second term. This will be our third term. Usually we do 4. When we substituted the 1, by the way, in a t-chart, we know that the x is the left-hand value, and the y points are going to be on the right-hand side of the t-chart. Anyhow, when we substituted into this formula the 1, we know we came up with 5, and it's exactly what we had here. So that'll be our first term. And then our next one, when we substitute in, is 7. And our next one is 9. And our last one, we could do it again, but we do see the pattern, and we see it up here as well. So we know that one will be 11. When we go to graph it later, we know that these are just ordered pairs. These are just x and y values on the graph. So we're just going to graph it just like we see those in a few minutes. So let's continue with, this one is a picture diagram, and let's say we were looking at number of seats. And let's say that all of these x's are chairs around some seating, and we add in another table how many more people can come each time. So if we look at our first picture right here, and all these x's are seats, we see that there are 6 available chairs for people. If we add up our x's for the next one, we see that there are 8 available chairs for everyone. And we continue along, and if we look at the next one, there's 3, 3 is 6. Now there's 10 available. If we continue the pattern without drawing them, you could draw them if you wanted, but we don't need to. If we continue the pattern, you know there will be 12 here, and there will be 14 here. They go up by 2 each time. But now what we're going to have to do is figure out what is the formula that will, or what is the equation that will get us this. If we want to look at it a different way other than finding out the difference, we can look at it as the picture, and some kids had some wonderful ideas when we did it. So to try to do this a different way, let's just look at it as a whole and as a picture and figure out what is the same and different as we go along to all these pictures. Well, first thing I see is that the short ends, here and here, have 2 chairs on the short ends, and there's always going to be 4 surrounding it. The 4 other chairs are on the length sides, and they are there all the time. But these, on each table, on each individual table, there's 2 chairs on the short and 4 chairs always around it. So if I look here, that happens. If I look here, we now have 2 tables, which would mean I would have 2 times 2 equals 4, plus my 4 other ones around it. They're always going to be there. And if we increase to 3 tables, again, we have our 2 on the ends and our 4 that never change. So to make an equation from that, we have to think, what can I do to it that will make this true every time? Remember, what we don't know is how many tables we're going to always have. So that'll be our variable, x. And we said one of the things we're going to do is we're going to have 2 chairs for every table on the width ends, on the smaller sides. There will be 2 chairs for every table. We don't know how many tables we're going to have when we do this, so that's why it's an x. And we also have 4 chairs always around the outside on the longer sides. And that's true in all cases. So this would be a great expression to do 2x plus 4. And it will check out, we'll check to see if it works using the terms 1 through 4. Remember, we use the terms 1 through 4 because it's the smallest. They're the easiest ones to graph when we start that. So we start with our t-chart. The work has already been done. We'll write 1, 2, 3, 4, and we use them because they're small numbers. That'll be x. That'll be y. Now, what we're going to do is we're going to check this out. We're going to substitute this value of x, 2 times 1, and we're going to see if it gives us this number. If it does, and it does it a few times, we're going to be great. I'm going to change colors because we've got a lot of green on there. Anyhow, 2 times 1 is 2, plus 4 is 6, and that will go right there, and that is 6, so that's the first term, works out well. But let's do it with the second term. If we had 2 tables, substitute that in for x, we add 4 because there's 4 always around the outside. 2 times 4 is 4, sorry, 2 times 2 is 4 plus 4 equals 8. That is our second term. That will be the one right here. And we just check it one more time. I know you're starting to see the numbers up there, and you're saying, Mr. Ross, why do we have to do all this work? Because it's good math. You're really training your brain on how to solve and check for your answers and make sure it's all right. Anyhow, 2 times 3 is 6, plus 4 is 10. We know that that was right because we counted the chairs, and there's 10. Now, we could substitute it one more. We could substitute it one more time, or we do see a pattern starting to connect. 6, 8, 10. We already have the pattern written over on the right-hand side, so we know that one's going to be 12. Once you have it in your T-chart, you know that these are just ordered pairs. That the 1, 2, 3, those are going to be your X values, and your 6, 8, 10, 12, those are going to be your Y values, and we're going to graph those in a few minutes. Lastly, we have some a word problem, and you will learn to make equations from a word problem. And what you have to do is look at what the problem is asked, and there will be something that happens to a variable, and then something else, because most things that we're going to do in grade 7 and 8, and definitely on into the future, are all going to be 2 steps. So anyhow, Bill likes to craft pottery at the local craft shop and kiln, and he has to pay $40 just to go in and use it, but then he pays $10 per piece that he sticks in the oven to cook. And we're trying to figure out what an expression is for the cost of a certain number of pieces. Now, I don't know how many pieces Bill wants to do. We want to make sure that this equation that we use will work for all of it. So the number of pieces, the one we don't know, that's what we'll put X as. That's our variable. And we know that it costs $10 per piece. If this is the piece right here, it costs $10 per. If he does one piece, it's 10. If he does 2 pieces, it's 20. That's $10 per. And we should know, hopefully, that we write that as 10x, 10 times the number of pieces, $10 every time he builds one. But we also know there's a flat fee of $40. We don't keep adding 40 and 40 and 40 every time that we do a piece. We only have to do that 40 one time. So that would be our $40. So now we have $10 times the number of pieces plus $40 to start. We've done a bunch of those this week, so that part shouldn't be too hard, but now we're going to put it on a T-chart. Again, we use our small numbers just because they're easier to graph, and we start substituting in. So this will be 10 times 1 plus 10. That'll be 20. So this one here is 20. We'll do it with 2. 10 times 2 plus 40. And that'll be 10 times 2 is 20 plus 40. So that's a total of 60. I've already seen a mistake. Must be getting a little tired. It's the end of the day. That's 40. So that's 10 plus 40. That's $50. My apologies, guys. As you can see, nobody's perfect. Everyone makes mistakes. I'm not upset. I just fix it. So yeah, so that's 50. And I'll do one more. I'll do it over here because I'm running out of room. 10 times 3 plus 40. 10 times 3 is 30 plus 40 is 70. I could do one more, but I definitely see my pattern is going up by 10. So that one there is going to be 80. What do I know? Well, I know when I do graph these are just my ordered pairs. Put them in brackets, put a little comma between them. We've graphed these before. And the first number in our T-chart is going to be an X. And our next number in the T-chart is going to be Y. So now we just have to graph them. Okay, so now we're starting to combine other things. We're going to graph, and we've done a lot of graphing. We know the first thing we have to do when we start graphing is to determine the scale. And our X and Y axes have different scales depending on the numbers. And we make different scales because it will look ridiculous if some of these numbers on the Y values are huge and the X values are really small, and you'd waste a whole sheet of paper just graphing it. So you choose the scale that will fit the data. Anyhow, in this X side here, we have the numbers 1 to 4. And we know that, that's pretty easy to put on, and our graph paper is pretty big, so we'll just make each of these ticks 1. You could make 2 of them, 2 squares 1, but for right now it works out fine. 1, 2, 3, and 4. We could put 5, we won't be using it here. Anyhow, but our Y value goes from 5 to 11. And we better make that, okay, we know we're going to start at 0, so we have a range of 0 to 11. I'm going to suggest we do it in groups of 2, that each square equal 2. And in that way, if we need to add in stuff later, it'll still fit. So that'll be 2, 4, 6, 8, 10, 12. And now we know our 11 will fit right in between there. All right. So when we go to graph this, we simply go along the line. The x value is 1, goes to here. And the y value is 5, so that dot would be right there. Our next one would be 2, so over 2, up 7. The 7 is halfway between the 6 and the 8. The next one is 3, 9, so we're here and here. And the next one is 4, 11. Now here's the important part. Please use a ruler. And I'm doing this by eye. I'm going to try to put a straight line through it. But if it misses a bit, you make sure that you draw yours with a line with a straight edge with a ruler. And the last thing we want to do is label it. So at the end, so we might be able to put multiple things on this line, we write y equals 2x plus 3. The only thing we've added is this y equals. And you could write 2x plus 3 and be happy with it this year. Grade 8s be ready to write y equals for next year. We don't have to tell you why. Just get used to doing it. Anyhow, here's our first one graphed. If we look at our second piece of data, let me put it up here on the board. There's our second piece of data, our second t-chart. If we look at our data, 1 through 4, that'll still fit, and 6 through 12, that'll fit as well. So we don't have to make a new graph. Let's use the one we already have. Hopefully the points are different. They might crisscross, but you don't have to draw a new graph for every single one you do. I'm going to use red this time. I'm going to do 1, 6 is my first set of ordered pairs. So I go over 1, up 6. That first dot is right there. Next one is 2, 8. 3, 10. And 4, 12. Beautiful. This one almost looks parallel to the last one. I'll get a red line this time. Try to get it right through the points, like so. The smartboard's off a bit. Anyhow, we remember that the line was 2x plus 4. We make sure we label it somewhere on the line. Y equals 2x plus 4. And we only have one more to graph. When we graph this next one, we see that the data, it's too big to fit on that last one. We have all the way from 50 to 80. We're going to have to make a new graph with a new scale. Not a problem at all. We spent a lot of time doing it. It's been a while since we did it, but that doesn't mean we can't go back and do just fine with it. So let me put a graph on here. I'll make sure these are on the lines because we want it to be, oopsies. Having a little bit of issue, I'll get it. There we go, on the lines. So the bottom line, the x-axis, that isn't going to bother us at all because it's still 1, 2, 3, 4. So when we do this, that'll be 0. How much do I got? 1, 2, 3. We'll still just go with 1, 2, 3, 4, 5. We don't need the 5, but we'll write it. Only because I didn't go any bigger with my paper. I'm trying to save paper. But now we have all the way from 50 to 80. And we know we're going to start that graph at 0, so we have 0 to 80. So we've got to figure out what scale we want to use. We have lots of room. We have 1, 2, 3, 4, 5, 6, 7 spaces we can use. So we could make each one, 10, but I have to add one in. So let's go make each one 20. This is 20. This is 40. This is 60. This is 80. This is 100. That's all the graph we need. We're going to write the first number, which is 1 and 50, which will be right there. The second number is 2 and 60, which will be right there. 3, 70. 4, 80. You use a straight line to draw it all. And that is not in the right spot, so let me just move it a little bit. Boom, like that. We label it, although I've forgotten what the thing is. Let me go back. That's graph, if I was to look at it, the equation was 10x plus 40. That was a big one. 10x plus 40. And we just label it right there. Y equals 10x plus 40. Basically, that's what we did. This looks like tremendously huge math. I know I spent 20 minutes talking about it, but I want you to all see we've been so happy and we've been so confident that we can do this. It's step by step, and we're going to practice it for a bunch more days. All right, good job, guys.